All right, let's go ahead and get started. Good morning, everybody. My name is Eric Bleas, and I'm the Southern Region Training Coordinator for the Mosquito and Vector Control Association of California. I'm pleased to welcome Dr. Niamh Quinn, from a Human Wildlife Interactions Advisor from the University of California. Today, she's going to be presenting on best management practices for anticoagulant rodenticides. We'll be taking questions at the end. So please put those in the chat box, and now I'll go ahead and pass it over to Dr. Quinn.
Thanks, Eric. I really appreciate you organizing this, and hopefully we'll get through everything. And if we don't have any time for all the questions at the end, I'll share my contact details at the very end, and feel free to drop me an email or give me a call. And so, as Eric said, I am Niamh Quinn. I'm the Human Wildlife Interactions Advisors with UC Cooperative Extension, University of California's Division of Agriculture and Natural Resources. And I'm mostly, actually almost exclusively focused in urban areas. And I'm going to talk a little bit today about our research around anticoagulant rodenticides and the pathways of those anticoagulant rodenticides into wildlife, and also some kind of best management practices that we're recommending based on some of the results that we have found. So why would you study anticoagulant rodenticides? Well, anticoagulant rodenticides are pretty much anywhere where you look for them. They're in birds, they're in mammals, and they're even in things where you mightn't even really expect to find them, like a Canada goose, and some of our other species that you wouldn't really think as your typical kind of non-target exposure cases. And we also have issues with them getting into our endangered species. So this is a photo from Jamie Rood from CDFW, who did her PhD on kit foxes, and you can see on the left that's kind of like a typical kit fox where you wouldn't find exposure, or you don't really see an exposure. And then on the right hand side we've got clear caligoopathy, where there's obvious exposure almost obvious exposure in this case. And we also see a lot of bad management practices, and I like to show this photo because this was taken right outside UC IPM's office in Davis. So kind of the home of IPM seems to be also failing, which is very interesting. And as I mentioned, we're finding them in our endangered species, so not just kit foxes, but also Pacific fishers. And then they're also found in a lot of charismatic megafauna, and you can't really get more charismatic megafauna than the mountain lion in California. And while mountain lions are under a lot of pressure from exposure to anticoagulants, there's obviously the added issues with connectivity, and just the fact that essentially the space use is disappearing, their habitat is no longer. So they have a lot of things to put up with, including the really scary drivers in Los Angeles as well. And there's a lot of media concern surrounding rat poison and its impact on our predators in California. And the data from California Department of Fish and Wildlife shows that there are a range of species exposed to anticoagulant rodenticide, and some that, like I said, you just wouldn't really expose, you would feel are exposed secondarily. So let me get my pointer up here. So this one here, like the Western gray squirrel, for example, like you wouldn't expect that a Western gray squirrel would get exposed to anticoagulants secondarily, or like a beaver. I don't know about you, but the thought of a rat, like a bunny that predates on rats, is kind of terrifying to me. So we really don't know in a lot of cases how anticoagulant rodenticide is moving up the food chain. And for example, like moles are insectivores, and you wouldn't really expect them to be exposed to anticoagulant rodenticides. Now, obviously there are other active ingredients that are registered for mole use, but not anticoagulant rodenticides. And then we're finding them in our birds of prey as well. And with the birds of prey, it's kind of obvious where it's coming from. Like, it's coming from exposed small mammals. The route of exposure there is a little bit more obvious. And there's also a ton of literature available of all sorts of flora or fauna that are getting exposed to anticoagulant rodenticides. There's also the Bloom Bill, and the Bloom Bill is the California Natural Protection Act of, now it's 2020. This thing has been around for a long time. And I just wanted to let you know that this bill has actually been heard today, and I'll share the link. It's actually been heard right now, but the bill itself is probably going to be later on in the day. But what it's saying here is that they're trying to place, I guess, a moratorium until reevaluation happens of brodifacoum, bromadiolone, difenacoum, and difethialone. And I actually have a couple of stars after difenacoum because the registrant is actually not going to extend the registration of difenacoum in California anymore, probably because it's just too awkward, and it's a fight to keep your labels in California right now when it comes to anticoagulant rodenticide. What might be interesting to the vector professionals is that under this act, vector professionals will still be able to apply anticoagulant rodenticides for public health reasons, thankfully, but there's no reimbursement required by this act. So that means that if this language doesn't change, that essentially vector control could be under an immense amount of pressure when it comes to the application of anticoagulant rodenticides. So it'll be interesting to see how this goes, because if the products are removed from the hands of the professional, what I foresee is that there will be a lot of pressure on vector professionals to apply anticoagulant rodenticides. And you'll see later on in the presentation, like that even though anticoagulant rodenticides are the preferred product to use, and we know that they're easy to use, and we know that rodents respond to them very well, you will see that there are certainly issues even with anticoagulant rodenticides from an application and success perspective, but those odds get even worse when you add an active ingredient like an acute rodenticide that we already know has palatability issues. However, on the flip side of all of that, there's also this, whereas, you just see these, particularly like very densely populated suburban neighborhoods, but also urban neighborhoods. And we know that there are disease issues. We know that they had typhus at City Hall in LA. And we know that they've gotten, people have died from leptospirosis in New York City. And as if we didn't have enough problems, now we have had our first human plague case in California as well. Now, second generation anticoagulants wouldn't be used to manage, squirrels, for example. However, once the second generation anticoagulants fall, it won't be long until there's a lot of pressure on the first gens also. And what's interesting, at one stage when this bill was being heard, there was also a terrible rat problem at the Cal EPA headquarters, where they were actually using anticoagulant rodenticide to manage the rats, and then stopped because obviously that's a PR nightmare. Started to use traps. They didn't work. They weren't used properly, weren't deployed correctly, because anything other than anticoagulant rodenticides is it's more difficult to use, and it requires a lot higher skill level from the applicator as well. And so they had to just go back to using rodenticides, which was really interesting. And there's also a lot of support in the literature too to talk about allergens, which is often something that is completely missed when we talk about rats. We know that rats and mice and things like cockroaches their allergens can cause early onset of asthma in sensitized children, although we don't know very much about roof rats in that case. But we know for sure for nori rats, there's also information on, things like, sole virus, salmonella. And then I have to share some nice pictures from my own experiences, which are maggoty rats falling from glue boards in schools. And pretty much all the disgusting rat pictures I have come from schools. Schools are just petri dishes of just filth. I don't understand how some of them are still open or able to serve food. If I ever have kids in California, they definitely won't be eating school lunches, because I've never seen anything like it in my whole entire life. This school here, this is rug marks on the hand railing in the area where the kids ate the food. This is feces in the stove. And so, you have the Bloom bill to support it on one side, but also there's the other side where, the industry thinks that, it's going to be hard to manage rodents without rodenticide. And one of the things about rodents that people I don't think really realize is that, we know more about polar bears than we do about commensal rodents, which is kind of a scary thought. So that bill will be heard today. and that's the link to listen to it. So if anyone's really good at multitasking, they can, you know, open that in their other screen and then tell us all when the bill comes on. I think it's like 17 or 18 in the list today, but they swap around a bit. If the bill passes through the appropriations today, it'll go back to the assembly floor for a vote and then straight to the governor's desk for signing. So it's not that far away from not having second generation anticoagulant rodenticides in the hands of the professionals. And so we've been researching our way to effective mitigation, because you can't keep stabbing in the dark. It's just a bad idea to make legislation like that. You know, you really need like science, like applied science, to try and find answers to some of these problems. And when it comes to what we know and what we don't know about rodenticide exposure in wildlife, I mean, it's really, really unbalanced. Essentially, all we know is that wildlife gets exposed. We really haven't looked at how that happens, and understanding how it happens can actually help you make better decisions about management. And I have a whole list of questions of that, but I do have a publication that kind of goes through, like, in a great world, how it would be best to assess kind of individual and population level effects of anticoagulant rodenticide in wildlife. So let's talk a little bit about who is responsible for anticoagulant exposure in wildlife in California and how potentially it gets there. And so I think this is a pretty good representation of a pest management professional. They apply rodenticide and it gets into the food chain. Now, we know that this is likely happening, but until very, very recently, there was very little evidence that any of these species actually consumed commensal rodents to any like high degree. Now, we know from some of our studies that this is happening. So coyotes do eat commensal rodents, and I'll talk a little bit about that later. Or this could happen where you have your pest professional, you know, legally applies rodenticides, and then something other than a commensal rodent enters into the bait station, and we know that those things are part of the food chain of these predators. And then maybe, you know, a theory is that mountain lions are getting exposed because coyotes are so loaded with rodenticide that it's actually a tertiary exposure. So coyotes expose something, and then the mountain lions eat the exposed coyotes. And we'll also talk a little bit about coyote exposure. Or here we have our vector professionals. And I know that, you know, some vector districts in California have very, very robust rodent management plans or rodent management programs, and they're applying thousands of pounds of anticoagulant rodenticide a year. And so it'll be interesting to see how does that application rate increase if the Bloom bill actually passes. Because if it passes, and it does increase from a vector professional perspective, we haven't really fixed anything. And then there's this route, and you know, this is kind of a popular kind of story that the professional applicator will be, oh, there's so much illegal exposure in California, and it's all coming from the homeowner. And so we know this is happening. We actually have evidence of this, that it's happening. And it's kind of, you know, it's always a misapplication. It's never done properly. And in that sense, then it's just a free for all. So let me talk a little bit about our wildlife in California and what's going on. And as I mentioned, we know that all these wildlife are exposed. We know that it's a lot of mammals, different classes of mammals, and then a lot of our birds. But just knowing that they're exposed is not good enough. We need to like investigate the pathways of rodenticides and the sources of exposure, because if we don't know those, we can't make it any better. And so we have this kind of complicated system that consists of our native species. It starts with kind of native rodents and rabbits and our mesocarnivores, and then kind of, you know, our top predators. But there's also kind of like the man-made kind of food chain, which is, you know, our anthropogenic foods, like whether it's trash or, you know, the landscaping in our backyards or in our parks. You know, pet foods, obviously commensal rodents are not part of the natural ecosystem. And things like free roaming cats, which I know our vector professionals in Southern California love. Great little typhus bombs right there. But then there's also the complication of how all of this how our practices influence this. So our land use and management, our use of rodenticides, is there TNR or feral cat feeding, or this new return to fields kind of craziness that goes on. And then obviously we have lethal control to some degree of our predators. And so NPMA funded a small, actually it wasn't a small project, it was actually a master's research project, to try and gain a better understanding of what happens at the application level. And so we really start to kind of pick apart this whole kind of food web. And one of the questions we had was, can above ground baiting reduce the risk of primary exposure and maybe even secondary exposure? And so we use the Master Gardeners of Orange County. We use their backyards. They're wonderful people, and you'll hear how wonderful they are when I tell you what else we did in their backyards. And we legally applied like non-toxic matrices. So I don't know if you're familiar with things like Detex or Leafetex rat and mouse attractant, but both of those are essentially the matrices of rodenticide, but without the active ingredients. And so we applied them in bait stations, anchored on the ground, and then in the tree as well. So about a meter and a half off the ground. In the first 30 days, we got everything but the kitchen sink. The only thing we haven't detected essentially is the mountain lion in our suburban systems in California. And so I want to talk about a little bit of what we found. Well, we found a ton of rat activity. And as you would expect, it was very, restricted to the darker hours. But we did have some, even in the areas, we did have some activity in times where it was slightly brighter. And obviously you can see that there's minor detections during the day as well. The number of rat detections per day was essentially phenomenal. Like, there's an insane amount of rats in the suburban system in Southern California. Now we monitored 2 bait stations in 30 yards a month over about 6 months. And so over the 30 or so days we did it, you can see that we were detecting rats almost instantly. Now, the discovery of the bait station and entry into the bait station is highly variable, but it can be significantly delayed. So like, it could be up to 20 days in some cases, where the bait station wasn't discovered or entered in that time frame. And so that's very, very telling about how difficult it is to manage rodent populations. And I want to talk a little bit about what we did detect. Now, there's a difference between detection and entry. These are all detections, what was around the bait station. And you can see that we took like pretty much everything. And I'm going to take out the rats for a minute just to show you that essentially keeping your bait station elevated would at least restrict access somewhat to everything but your eastern fox squirrels, which are very arboreal, obviously. And now we know that eastern fox squirrels like bait stations, because this is what they did to ours. They literally mowed side, back, top. But we do know that squirrels, especially tree squirrels, are very attractive to one particular soft bait, and so there are ways around that. So it depends on what you apply in your district, but if you are having issues with tree squirrels getting into your bait station, obviously that's horrendous and you need to fix it. So the options are either to stop baiting or to switch your matrix, and usually when you switch your matrix, that can help as well. When you look at non-targets and access to the bait, we actually didn't really have that many non-targets enter the bait station. And so this is proportion of detection versus entry. And so you can see if we detected deer mice, they were very likely to enter, and less so for the other species. We did have 1 juvenile possum, but actually very few non-targets entered the bait station, which was kind of a big surprise for us. And we had thousands and thousands of trapping days and nights where we essentially hardly detected any non-targets getting into our bait station at all, which was a big surprise. Now, obviously, any non-targets entering a bait station that's a big deal. It shouldn't happen. It's against the law. And we have some suggestions of ways that you could get around it. But you can see, squirrels are big enough. But we did have, some mesopredators try and get in to the bait and try and, shake it out and get it out and pick it up. And like, they're really trying to get in there and did not succeed in getting the bait out. So that's good news in that sense. So let's talk about what we know and what we don't know now. Well, primary exposure to non-target wildlife from legal applications of rodenticides for structural pest control is unlikely to be a major route of exposure, and that surprised me a lot. So exposed non-target preys of carnivores are unlikely to be a major pathway of exposure, and that was, for us thinking that coyotes don't eat rats and then finding this out, it was, we were a bit boggled. What we do know is that primary exposure could be mitigated by applying a rodenticide off the ground for sure. We also know that rats respond to bait depletion, and this is really important, and especially for vector professionals that might not service their bait stations as often as they should, mainly because of other pressures, like during mosquito season, etc. But bait stations without bait can kill rats, and you have to monitor bait very, very closely. And we found that in particularly in high populations, when you change the bait, what you get is you get this huge peak and then it drops off. Now, our bait was non-toxic, so we're not really sure what happens. But the idea is that like it could be this could be indicative of population recovery if you use a toxic bait. Because if you don't bait enough, what you're going to do is you're going to bait, you're going to kill your rats, you're going to let the population recover, you're going to bait again, kill your rats, let the population recover. And what you're doing is you're just putting more intoxicated rats into the environment. Now, what we know is that the presence of non-target wildlife, particularly native rodents, can be predicted by yard type and distance to green space. And so the closest you are to green space, coupled with if you have a permeable fence, the chances of you having a non-target wildlife in your yard are much higher. And so then you want to think about how that has consequences on the the wildlife that are in that area. Now, this yard, for example, doesn't have a permeable fence, and it's not close to a green space. So this would be more ideal for a second generation anticoagulant rodenticide application than somewhere that has a permeable fence. Now, what's really interesting is that rats only entered about 59 to 70%, depending on where whether it is a ground or an elevated station. And so this is of the rats that encountered the bait station. They only entered about between 59 and 70%. That's a huge amount of stations that rats came to and never went into. Which is insane when you think of rodent management and the effort that is spent to do that. And then it's even crazier if you think that we know that rodenticides are palatable, and there's hardly any issue with bait shyness. Then what happens when you add the active ingredient? So that's that could be a huge complication if this bill passes. Excuse me. So we also looked at how else wildlife were getting exposed, and I told you that the master gardeners were amazing people, and they're amazing people because they let us put dead rats in their backyard to see what happened to them when they as a carcass. Now, we know nothing about how wildlife preys on exposed species. We don't know how they prey on them. Are they hunting like live exposed rodents, or are they scavenging on dead intoxicated rats? It's very interesting. We just don't know. But what we do know from this project is that a huge amount of carcasses were removed really, really quickly. So, our predators are nearly able to detect our bait stations before our bait before our rats are. And by the end of our trial, which only lasted 7 days, because while the master gardeners are great people and all, they're not going to let us leave really maggoty rats in their yards forever. But A lot of the carcasses had been completely removed, or at least partially removed, and almost everywhere the carcasses were interacted in some way, shape, or form. And what's really interesting is you know, we even had rats feed on rats, we had dead rats, we had all sorts of things come in and pick them up. You know, feral cats potentially could be a part of the pathway as well. You know, we had birds, and we had other things come in and feed off of maggots that were feeding off of the carcass. And so the invertebrate pathway is very underexplored, and that could also be a way that wildlife is getting exposed to, especially wildlife that we're kind of confused at how it's getting exposed because it doesn't eat bait, like for example, like a mole, for example. And so, you know, managers of rodents, we need to find out ways to recover exposed carcasses, but I couldn't tell you how. I have no idea how we do that, how we figure out where rodents go to die. Now, it's probably less of an issue with roof rats, maybe, or not roof rats, but nori rats, because they're burrowing rodents and they may be more likely to die below ground. And that certainly is the case with ground squirrels, and I'll share a little bit about that later on as well. But it's kind of a puzzle, and like I said, we know more about polar bears than we do about commensal rodents, and it's ridiculous because commensal rodents are in our lives every single day, and polar bears certainly are not. So one of the questions we tried to get to the bottom of was how are carnivores getting exposed secondarily? And so this is our kind of complicated food web, and we're still trying to pick it apart. But what we decided to do was trying to look at, like, what do coyotes eat, and in those things, what could be exposed. And so scat analysis is a really bad idea for any kind of diet study, particularly in Southern California, where there's a multitude of animals and their poops all look fairly similar, even though people will tell you that they're not. But about 50% of experts misidentify scats. The only way to do it is to do it molecularly. So what we did is we took the stomach contents of coyotes, and we also did some molecular analysis where we made the molecular margarita in the blender once Danielle, our first student, was finished with the content. We've necropsied, I mean, it might be nearly over 600 at this stage. They just come from everywhere. They come from, you know, federal, state, county agencies, cities, pest management professionals, and we find all sorts of things in our coyotes. I mean, can you even imagine how difficult it is to poop out a red-eared slider? I just don't even want to imagine. So here you can see what we found. And we're just starting to try and publish, actually, but this study has been submitted and we're getting ready to submit the last study for publication. And, you know, cats are a humongous part of the diet of urban coyotes in Southern California. But if you look, commensal rodents are a serious, they're detected in almost 35% of our coyotes, and that's way higher. And by way higher, I mean before this and one other study in Los Angeles, there was literally no evidence of roof rats in the diet of urban coyotes. And so that is a potential way that rodenticide is getting into the population from legal applications of second generation anticoagulant rodenticides. And obviously, but there's a ton of other potential sources of second gen. Now, your rabbits could be a source of first generation anticoagulant rodenticides, but we wouldn't really expect them to be getting inside bait stations, although I think that juvenile rabbits could. We just never detected them. But, you know, there's a lot of cats potentially you know, interacting with a lot of rodents, so it would be interesting to test feral cats for anticoagulant rodenticide. And so we've tested our coyotes for anticoagulant rodenticides, and it's hard for us to find ones that are not exposed, and they're exposed at fairly high levels. You know, mostly second generation anticoagulant rodenticide, mostly bromadiolone, which is probably the most popular active ingredient in California, but also a large amount of difascinone as well. Difascinone is probably more popular, but it's also, well, at least in the blood, but this was the liver. In the blood, it's very polar. It's much easier to detect. We also detected, if you see here, coumatetrolil, and we've now detected coumatetrolil multiple times in Orange County, and coumatetrolil is not a registered active ingredient in the US, never mind in California. So we've actually detected coumatetrolil, an illegal active ingredient, more than we've detected difenacoum, which is just not really used that much. So if you go back to what we know and what we don't know, what we're learning from this project is, the detection of cume tetralyl is evidence of illegal applications of rodenticide in Southern California. Now, obviously, it could have been made by a professional, but it's very unlikely that it was. And this discovery led me down a very, very strange path of trying to buy and access as much illegal rodenticide as I possibly could over the internet. And guess what? I was actually really successful. And it was kind of terrifying how easy it was for me to buy all of this stuff, most of which are not registered products, and some of which were repackaged that were just said. This one was like was a party pack, a poison party pack, which was literally how it was advertised, and saying, oh, it works great, don't let your dog eat it, or something like this. We don't know what this is, but it looks very like a professional product, but it could in fact be counterfeit, unregistered, active ingredients. And then none of these products here are registered in the US. Well, this one is, but most of them are not registered in the US. Now, these are registered in the US, but they're obviously repackaged, and that's illegal and no label. And so the big question we were asking here is exposure to urban coyotes from legal applications of anticoagulant rodenticide by pest management professionals? And it is likely that it is. It's hard for us to connect the dots precisely, but if you think that hardly any non-targets are getting into the bait station and the coyotes are eating so many rats, it is likely that roof rats exposed by legal applications are a major pathway. But the second question is that, does it even matter? Are anticoagulant rodenticides having population level impacts on coyotes in Southern California? And anyone that lives in Southern California will tell you that coyotes are essentially just everywhere now. There's no evidence that they've expanded their range, and there's no evidence that their densities are higher, but it is likely. But just because it's not having a population level impact doesn't mean that it's not having some sort of sublethal impact. And so we are researching the sublethal impacts of exposure on urban coyotes. And I have the most fantastic group of students that very enthusiastically do the grossest things ever. And this is Ariana with a tapeworm, looking way happier probably than she should be. And what Ariana is doing is she is looking, and this project and our last two projects actually are in collaboration with the STAP Lab at Cal State Fullerton. And so we're looking to see, even though our coyotes are not dying of anticoagulant exposure, is it having any other potential impact on its health? And one of our problems with this project is that Ariana picked 50 animals, like just randomly 50 animals that we got into the lab, and necropsied them, and then we sent them off for anticoagulant rodenticide testing, and 50 out of 50 were exposed to anticoagulant rodenticides. 49 out of 50 of them were actually exposed to bromadiolone, among other things. But there's just huge levels of anticoagulant exposure in coyotes, and it kind of makes me wonder about resistance. And we know that there's rodenticide resistance in California, but there's no way for us to really measure that yet. Someone really needs to look into it, and we would like to look into it. It's just kind of down the list a little bit, and it's costly, but we're hoping actually to do a small rodenticide resistance pilot study with Orange County Vector Control in the future, because it's really important that vector professionals do not put anticoagulant rodenticides into the environment if they're not doing anything, and all we're creating are essentially little rodenticide bombs that just eat the rodenticide. It doesn't kill them, and then they go off and they actually, impact either lethally or sublethally something up the food chain. We also had the rodent management work group, and we were lucky to have some representatives from the vector industry there, from Alameda and from Contra Costa County. And we were really interested in trying to develop research-based IPM for agriculture and structural rodent control. We had a great 3-day workshop, but what we learned is that 3 days is just not enough. There's just so many issues surrounding rodent management in agriculture and structural rodent control that we need like 3 years, never mind 3 days. And so we're just getting ready to write this up and submit the final project report for NPMA. So hopefully that will be available soon. this is like my project baby, and I'm finally like 10 centimeters dilated. It's taken me a long time to birth this project. This project is funded by the Structural Pest Control Board, and we're trying to isotopically label a rodenticide to try and trace it up the food chain. And in the process of doing this, we've also realized that we can actually hopefully create a non-lethal way to monitor rodenticide exposure through a population and through an individual. So we will be able to look at individual effects over time non-lethally, and also population level impacts as well non-lethally. And so this is a project in cooperation with industry, but also with the federal government and a couple of different universities. And it's kind of crazy, but it involves essentially poisoning rats. We've created our isotopically labeled compound. We have to feed it to the rats, then we have to feed the rats to the coyotes, and then we have to kind of set it free, the compound free, in a pilot study when we figure out if we can test it up the food chain. But this whole process is allowing us to develop methods as well, with hair and feces and maybe even feathers up the ladder a bit, that will allow us to go through and test your population. So, maybe this will be an option for vector control districts in the future to able to monitor how their programs are impacting, the environment essentially. Now, right now, I wouldn't recommend that you do it because it's going to cost you like $50 bajillion to isotopically label your compound. But we're hoping that, as we develop our methods, that we'll be able to, just make it easier for people to assess environmental consequences of actually all toxicants, not just rodenticides. And what this project does is it really lets us look at this whole entire system. As I mentioned, we know more about polar bears than we do about commensal rodents. And so we were lucky enough to get funded, and it's kind of a long story. We got funded by a grant. It got officially awarded and then officially taken away again. And then we got awarded a contract. And then coronavirus happened, and then we got delayed, and then the Bloom bill hit. And so this project it was 100% funded, but it's kind of, it's on pause at the minute because we have a lot of upfront costs, and obviously the department are worried that we're going to spend a lot of money trying to figure out what's going on with rodents and rodenticide, and then all of a sudden there's going to be no rodenticide. So I think it's kind of short-sighted in their eyes, but it's, because people are still going to use rodenticide. So our vector control agencies are still going to do it. There's still use, and there are exemptions for anticoagulant rodenticide use, because so these practices are still needed. And I have developed a best management practices team, and we do have some representatives from vector control districts across the state as well. Another thing that we're trying to do is kind of indirectly trying to monitor coyotes to see if their densities are in fact increasing, and that's kind of a backdoor of looking to see how anticoagulant rodenticides might be impacting urban coyote densities. Although this project is solely a coyote project looking at coyote management, this will be kind of a backdoor into it. Now, I said I would mention some of our squirrel research, and so I collaborate with Dr. Roger Baldwin from UC Davis on this. This is Ryan down a squirrel burrow trying to recover a dead collared squirrel. And so we're looking at secondary toxicity risk from the application of a first generation anticoagulant rodenticide, which are also probably very commonly applied for a plague vector by vector professionals. And so it is concerned that this could move up the food chain, especially given some of the areas where these things are controlled, like campgrounds, areas that would be visited by a lot of predators. And so what's very, very interesting about this is that a lot of the California ground squirrels are actually dying below ground. Now, there's not all of them are dying below ground, but when you look at what is happening, it seems like a high proportion of squirrels that are killed by a first generation anticoagulant rodenticide are in fact dying below ground. So, even though, yes, ground squirrels in particular are probably a source of exposure, it doesn't seem like they're a huge source of exposure. And then what's interesting on the flip side of that is that this project here, which is looking at the exposure in coyotes, now we have a very small sample so far, just 32 individuals, not like our 300 or something that we've tested in urban areas, but 63% of these coyotes had no exposure at all. And 22 of them had exposure concentrations of hardly any rodenticide at all, which is really, really interesting when you're looking at like the impacts of first generation anticoagulant exposure on predators. And so that's something to think of as a vertebrate, like as an applicator of vertebrate toxicants, is that yes, they do move up the food chain, but like how much of an impact are they actually having? And are they having any population level impact? And we know that there's no evidence that applications of anticoagulant rodenticides do have population level impacts, although just because there's no evidence doesn't mean that they're there. So there is need for more research. And so, yeah, it's difficult. There's a lot of things going on. And, we really don't know the full story. And I think that it's interesting that the legislator has gotten involved because there's huge pressure to ban anticoagulant rodenticides. Yet we still have maggoty rats falling from the ceilings of schools. We still have, people getting plague in California. Yes, it's once in 5 years, but that's still too many times. And so, it's important that we have these tools. And, if this bill passes, the role of the vector professional applicator is just going to be immense. And I think that there is going to be a lot of pressure on this audience to apply anticoagulant rodenticides because they're easy to apply. We know that they work fairly well. At least we know that, well, we assume that they work better than some of the acute rodenticides. And then if this bill passes, my prediction is that it won't be long before the first generation anticoagulant rodenticides are under huge amounts of pressure as well, especially difecinone. And difecinone is kind of a funny one. So there has been some work on mange in Southern California, and it has been said that mange is linked to the exposure to anticoagulant rodenticides. However, on the flip side, there's also research from the federal government and the National Wildlife Research Center that shows that there's no immunosuppression impacts of cats when they're exposed to bromethylin, brodifacoum, and brodifacoum is probably one of the most toxic anticoagulant rodenticides. And so very conflicting research there. But the thing about difecinone is that they found a huge amount of difecinone in the bloods of the bobcats, but difecinone is very polar, and so therefore it's readily detectable in blood, and so it's likely that the other active ingredients were there too. It's just that just them, not saying the methods were bad, but the interpretation of the results is not exactly accurate. So that's interesting. So when just to summarize, when we talk about what we know and what we don't know, it's hard to give recommendations on management. Yes, we're learning more and more and more from what we know. And we know, for example, things about urban rodent management that we should have known decades ago. And roof rats in particular are just so understudied, and we hardly know anything about them. And so we have this really unbalanced kind of approach to rodent management where we're kind of just constantly stabbing in the dark. We don't know what's happening because we're stabbing in the dark for rodent management. When it comes to wildlife management and like rodenticide exposure and the pathways and trying to find the source of the exposure and then trying to interpret it, like if there's individual or population level effect, we're really, really struggling to make those decisions. And what I keep saying is that if you don't know how something is broken, you can't fix it. And I think that's what's happening here, is that we have all this legislation that's being proposed. And for example, if what happens, if the bill is passed and vector professionals can still apply anticoagulant rodenticides, we will still have exposure. We won't have fixed the problem. And so hopefully some of the things that I talked about today, you can think about incorporating those into your programs. It's definitely not a fix, but it is something that you can use to help reduce exposure to wild populations, and that is very, very important. And so, you know, I have this great team that I work with. You know, Dr. Paul Stapp is at Cal State Fullerton. He's just a brilliant mammologist, and he entertains all my crazy ideas. And so I go to him with a crazy idea and money, and he comes back with great students. So Danielle here, Danielle actually works for me now, and she's actually doing some rodent research, but she did the coyote diet study, and Danielle is quoted on the front page of the LA Times as saying that it's like Christmas every time she opens a coyote stomach. It's like a present. She never knows what's going to be in there when she unwraps it. So definitely a special woman. Jen here is the woman that makes the molecular margaritas, and she has done the DNA analysis and has really done a fantastic job of something that's very dirty and not easy to do, with support from Dr. Walter at Cal State Fullerton. Brandon Latz, Brandon was the one that left the dead rats in the Master Gardener's backyards, so we definitely really appreciate him. And we have Ariana is our student that's doing our sublethal analysis, and so she's getting there, but she started a lot later than most of our other students, so she'll be getting done and hopefully moving on to vet school, which would be really exciting for her. And then Chris is the one that did the kind of the bait station study in the backyards with the ground and the elevated bait stations, and so Danielle's research has been submitted for publication, and we're getting very close to Chris's as well. And then, you know, Roger Baldwin up at in Davis, he is the specialist, the human wildlife conflict specialist for the state. He's the only one. It's just almost ridiculous. For a while, it was just me and Roger, but now luckily we have a colleague in the Bay Area. But Roger mostly focuses on agriculture and production agriculture, whereas I'll focus a little bit on non-production ag sometimes. So, you know, parks, campgrounds, things like that, which is technically agriculture when it comes to talking about pesticide. But there's not a lot of support for rodent management in the state. There's very few people. It's hard to find students that want to do applied research, although we've been really, really lucky. And it's just, you know, there's essentially a sea of entomologists in the United States, and while entomologists are lovely people, you know, there's not one single endowed chair for rodentology in the country, and so it makes it difficult to even find solutions that could potentially be simple, although trying to figure out urban rodents is not easy. And then obviously, as you guys know, trying to apply pesticide in the urban environment comes with a whole range of challenges as well. So that's pretty much all I have to say for today. You know, please, if you ever have any questions, I am so happy to answer them. And the best thing to do is to email me right now. I can be in the field a lot, so my response can be a little bit delayed sometimes, or my inbox can explode also. I didn't think my inbox could get worse, but coronavirus has seen to that for sure. Definitely feel free to give me a call and leave me a message. I am not in my office, so I will not answer my phone. Although if I even was in my office, I still might not answer my phone. Please also follow us on social media. We tweet at the Southern California Urban Wildlife Management Council. If you're interested in our coyote project, where we tag and follow urban coyotes around Los Angeles County, that's on Instagram at Cosmopolitan Coyotes. And then also, if you're interested in kind of some of our projects, we don't have all of them up there, but we do have most of them. You can find it at the University of California's Southern California Urban Rodent Research Initiative.com, so ucscurry.com. So hopefully we'll have some time for questions.
Thank you very much, Dr. Quinn, for the great presentation. We don't have anything currently in the chat, but if anyone has any questions, we got one coming through right now. Let's see. All right, so if the bill passes, are there research areas that you recommend or encourage to show what our impacts are, and who else SGARs may be getting into the food web?
Yeah, I see the question there, and I think that from Jennifer, I think that's a really valid question, because what happened with the restrictions of anticoagulant rodenticides is that it put a bullseye in the back of the professional applicator. And so because a lot of people don't really understand how their municipal governments work and what some of the roles that they play, like they probably don't know that all that's going to happen essentially, probably, and this is just a prediction of mine, is that the application is just going to switch from one group to the other. And you're right, the target will be on your back as vector professionals. And so I just hope that, because your applications, and I mean everyone's applications are for public health, but like as a vector, you're an agency as regards to for profit, that you might get away with it, but I don't know. But like I think that, you know, knowing what your potential impact is, at least it's important, because I think what's happened with the professional industry, as in like the more pest professional side, is that they've had their head in the sand this whole time. And we talk about this all the time with the pest management professionals, where they have just assumed that they weren't part of the problem. And now that, I wouldn't say that we know that they're part of the problem, but we know that there is definitely an issue. We know that wildlife's getting exposed. We know that wildlife eats exposed rats. We know that it's probably not coming from that many non-targets. And so it doesn't take a lot to connect the dots. And so I think as a vector agency, like, it's important to protect your resources, but like I don't really know how you do that. But like I think that there is a lot of, you know, there's a lot of things that you probably could do, like, you know, like if you do sewer baiting, like what eats your sewer bait? Do you even know what eats your sewer bait? Do you know how long it takes for your sewer bait to be consumed? Have you ever put a camera on your sewer bait? You know, what about cockroach consumption of your sewer bait? Like, are cockroaches exposed to anticoagulant rodenticide? We don't know any of these questions, or the answers to any of these questions. And I think that, you know, there's not that many people that can do rodent research, and I think that vector agencies are certainly ones that can do it, and at least do pilot studies into it that can help, you know, people in universities make more informed decisions about how they direct their research as well. And there's, you know, there's definitely agencies or districts out there that do fantastic jobs with their rodent research. You know, Orange County, Alameda County, I know for sure, and I'm sure there's other ones out there that you know, they're going to the vertebrate pest conference, they're publishing them in the proceedings, and that's really important to have the information out there. So as a vector agency, like if you do this research, like we need to know about it. So it's unless it comes to a venue where the science, like the rodent researchers are as well, then we won't be able to connect the dots in the middle.
All right, thank you very much, Dr. Quinn. All right, one more just came through. How would you prevent non-target animals from chewing up the rodent traps? Are there newer types of bait stations that are preferable?
It's almost impossible to stop rodents chewing. And so I don't know if you mean like non-target wildlife. So it's unusual for non-target wildlife to beat up the bait stations, but they will. Tree squirrels in particular, ground squirrels will as well. But as I mentioned, the tree squirrels are very attractive to soft baits. And so there's soft bait is kind of like the new kid on the block. It's preferred by a lot of applicators because it's thought at least to be more palatable, and it would at least seem that, although I don't have any actual evidence that it is. But it's kind of greasy, and it actually kind of, I think I could eat it actually and like the taste of it. It's kind of like a peanut butter cookie dough type thing. Now I have no idea what's in it. but it kills rats as well as the blocks kill rats. And so if you find that if you're using different matrices and certain wildlife are attracted maybe to this kind of oily, kind of peanut butter, kind of cookie dough type little sachet soft bait, just switch back to another, switch back to a bait and see if, or a block, and see if that makes a difference. The way that I would suggest that we would stop non-targets getting at your bait station is to put it in a tree, because we know from our research is that the chances of non-target wildlife interacting with a bait station are significantly reduced when you take it off the ground. It doesn't necessarily have to be in a tree. It could be on a fence line. It could be on, just raised above the ground. And that's a good way to stop non-targets getting at the bait. And we know that works. And we also know that there's no significant difference of detection. And even though it's not significant, about 70% of rodents that encountered bait stations above the ground entered them, and about 60%, I think it's 59% of rodents that encountered bait stations on the ground entered them. So there is a difference. And so it could be that if we did more sites, that there would be a significant difference, and that rats would more readily enter above ground bait stations, although that's not exactly, we didn't have a significant result in our case. So yeah, just take it off the ground. Simple as.
Sounds good. Well, that looks like it for now. Again, thank you very much, Dr. Quinn, for taking the time. Wait a little bit longer, see if anything comes through the chat. But if nothing comes through, I think that's it for the day.
Yeah, no worries. And like I said, if anyone has any questions, I'll just share my contact details again there. And just feel free to send me an email, give me a call. If you want to chat, we can set up a time. If you need to, if you want to toss around some ideas for different programs at your districts, I'd be happy to chat.
All right, sounds good. Well, nothing came through on the chat, so we'll go ahead and end the meeting.
All right, thanks.
Thank you very much. Everyone have a good day.